There's a lot of vocabulary. This section's really easy, but we've got a couple new vocabulary words. The first one is a rate.
It's still on freeze.
Oh, thank you. So, who can tell me what a rate is?
A rate is like
Nick.
A rate is a ratio that compares two quantities measured in different units.
Uh-oh, somebody swallowed a textbook. All right. So let's put that in non-super textbooky terms. What's a rate?
how fast something goes.
Okay, that would be an example of a rate. You could talk about a rate. A speed is a rate. Okay?
Kind of like a sales rate?
Okay. Okay, so you guys are giving me examples of rate, which is good because it means you have some understanding of what rates are.
It's like an average or something like speed, like average.
No, it's not. It doesn't have to be an average. You can talk about an average rate, but not all rates have to be average. Nick?
Ratio?
Okay, a rate is a specific kind of ratio, but yeah, it is a kind of ratio.
It can be a measurement.
It can't be a measurement. Here's the main thing you need to know about rate. A rate is a comparison. Okay, it's always comparing two quantities, two amounts. So, an example of a rate. Now, someone talked about speed.
Trend.
Okay. So, what would be an example of a rate using speed?
Somebody went 70 miles on a curve.
Okay, 70 miles per hour. Okay, the reason that that is a rate is because, I mean, if you just said, hey, I drove 70 miles, that's not a speed. It's also not a rate, okay? Because it's not comparing the amount of time it takes you to the amount of distance you traveled, okay? The reason that speed is a rate is because we're comparing the distance we travel to the amount of time it takes us to travel that distance, right? So that's why that's a rate. What's another example of a rate? Nick? Huh? Okay. Who knows another example of a rate? Somebody gave me another example. Awesome. Width and length are each a single measurement. You've got to be comparing two things in order for it to be a rate.
It's like the normal span, like how it goes. No, I'm stupid.
A sales rate.
Okay, a sales rate. What are you comparing in a sales rate?
The price.
The price to,
The average price.
okay, the number of
price
items.
to the sales price.
Okay, so you can compare, the actual price to the sales price, okay? Now, there are lots and lots and lots of rates, okay? If we talk about any comparison of two numbers, you can compare any of your parents on diet, gone on a diet before? Okay, if they've ever been on a diet, then you may see them reading all that little nutrition label on the side of boxes of things, because that tells you a rate. It compares how many calories are in each serving, or how much they've eaten of it. So they're looking at, okay, if I eat this much, how many calories am I taking in? Or if I eat this much, how much fat am I consuming? So you're looking at a comparison. Okay, so rates are always comparing two quantities. The important thing is they're two quantities. They're two real things. Okay, a ratio is something as simple as 3 to 4. That's a ratio. But it's not a rate because it's not two things, it's just two numbers. Okay? Whereas if I say 3 dentists out of every 4 dentists surveyed prefer Crest toothpaste, well, now I have a rate, because now I'm comparing two quantities. I'm comparing a number of dentists to a different number of dentists. Okay, so a rate is a comparison, comparing one thing to another. All right, a unit rate, which is what we're going to look at today, is probably the rates that you're most used to hearing as rates. For instance, when we drive down the road, we measure how fast we're going in miles per hour. If I'm going 60 miles an hour, what does that mean? Ryan?
In an hour, you're going 60 miles.
Okay, it means that if I stayed at that rate for an entire hour, then I would travel exactly 60 miles, right? Okay, now, if I travel at 80 miles an hour for an hour, I would travel exactly 80 miles. Now, of course, we increase and decrease speed as we come to traffic and red lights and get off the interstate and get on the interstate. But the whole thing with a rate is it's telling you, hey, if you kept this constant rate, your speed would be, you would travel this distance in this amount of time. Now, the reason it's called a unit rate is because it's per 1 hour. Okay, the only difference between a rate and a unit rate is a unit rate is always per 1 of something. Okay, so for instance, when we were just talking about people on diet, you know, if you look on the box, they have the number of calories per serving. How many servings are they talking about? Just one, right? So calories per serving is also a unit rate. Ivor, you need to wait until I'm done teaching. All right. You could also have MPGs. You hear this a lot on the car commercials now. What are MPGs? Miles per gallon. That tells you how many miles you can travel on 1 gallon of gas, right? Any of those per something is going to be an example of a unit rate. Now, all you're going to be doing on the homework tonight is finding some unit rates. So, for example, it says, during exercise, Sonia's heart beats 675 times in 5 minutes. Now, we want to find a unit rate. We want to know how many times it beats per minute. Well, here, this is a rate, 675 beats in 5 minutes, right? And now if I want it to be a unit rate, I want it to be per 1 minute. Well, there's a very easy way to do that. Who knows what we need to do? It's okay. You're going to do division because this is a fraction, and a fraction is no more than a division problem. Or you can think of it this way. The way they have it shown in the book is, if I want it to be per 1, then I need the bottom number to be 1. So I have to divide by 5, which means in order to have an equivalent fraction, the top number gets divided by 5. Now you can do it that way, but really the easiest way to think of it is simply the top number divided by the bottom number. So 675 divided by 5 does give me 135, and that's going to be measured in beats per minute. So for unit rates, all you have to do, let's look at another example. So it says, to make 4 large pizza pockets, Paul needs 14 cups of broccoli, and let's see, and that's to make 4 pizza pockets. So it says, how many how much broccoli does he need for one large pizza pocket? So what do I want one of?
$1 million.
One pizza pocket. So that means that's what goes on the bottom. And the amount of broccoli goes on top. And then we divide, and 14 divided by 4 gives me 3.5. So I need 3.5 cups per pizza. So, for this, guys, so for each one, the thing you need to ask yourself, because in this problem, in the last one, it said to make 4 large pizza pockets. So it gave you the 4 first and then the 14 next. But notice it wasn't 4 over 14, it was 14 over 4. You need to pay attention to what you want one of. We want to know how much broccoli in one pizza pocket. So the number of pizzas goes on the bottom. Whatever you want one of is what needs to go on the bottom. Because to determine your unit rate, you're dividing by the bottom number, which means you're getting it per one of the bottom number. So that's all, really that's all you have to remember. The only other thing is you will need to round some of your answers. You're allowed to use calculators for it, of course. You may get crazy decimal answers for some of them. On all your homework questions, you're asked to round to the nearest hundredth. Let's say that my answer on a problem is 2.7592361 something else going on. Hundredths place means 2 places after the decimal. The number that follows that tells you whether it's either going to be 2 and 7,500 or it's going to be 2 and 7,600. So all you have to do is use this digit around 9 rounds up, so it'll be 2 and 76. All right, make sure and get your homework done tonight.
I gotta help Charlotte.